regarding example 2, use the graph of f, well it says above, but it's actually to the right. All right, here's our graph of f right here, to fill in the 3 blanks below with the following. All right, so we have to put f of 0, f prime of 0, and f double prime of 0 into this compound inequality. In other words, we're going to order these from least to greatest. Least being over here, greatest being over there. So, we're interested in f of 0, f prime of 0, and f double prime of 0. All we have, though, is the graph of f. So how do we get these 3 values from this? Well, this one's easy. F of 0, that's that point right there. Okay, so we know that f of 0 is equal to 0, because that graph goes through the origin. Now we have to figure out f prime of 0 and f double prime of 0. But we don't have the graph of f prime, nor do we have the graph of f double prime. All we have is the graph of f. So we have to use the hints from the graph of f to come up with values for these two. Okay? For example, this graph of f, well, it's always increasing. So let's make note of that. Right? F is increasing. And while we're at it, let's talk about the curvature of this graph as well. How would you describe the concavity of this function? That's right, it's concave down. F is concave down. Why is this important? Well, let's bring in our connections again. Keep them handy. Okay. And we see that an increasing function means that we have a positive derivative. Right? So this derivative must always be positive. F prime must always be positive because f is always increasing. Right? So this information right here tells us that f prime is positive, right? Because f is increasing. What about concavity? This function is always concave down. Let's go back to our connections. And we see down near the bottom of our connections that when f is concave down, the second derivative must be negative. Okay, so since our function is always concave down, our second derivative must always be negative. If we bring this data back over here, we know that f prime is always positive, so that means that f prime of 0 is greater than 0. And f double prime is always negative, so that means that f double prime of 0 must be negative. Now we can put these 3 in order. The negative number is the smallest, so f double prime goes first. 0 is smaller than a positive number, so f of 0 goes second. And then the positive number is bigger than 0 and a negative number, so f prime of 0 goes third.